Okay, so let's talk about imaginary numbers. Talk about how they were developed, like the need for them, and then also how to simplify imaginary numbers. Okay. All right. So let's start here. Let's solve an even power. We'll get our lowest even. Right. So we're going to solve x squared equals 1. Now, I want to know before I solve this, what does this actually represent? What does this equation represent? So we've talked a lot about this, what equation means. It really just means that give me a number, and when I square it, I'll get a positive 1. That's what this means. All I need to do is find a number that when I square it, I get a positive 1. Well, easy enough to solve. We can just square root both sides. And since, remember, it is an even power, we're going to do a plus or minus on our square root. So we'll get an x on the left and a plus or minus 1 on the right. So then I have two solutions. And if we want to check these, we just plug it into the equation. So remember, I said before we started that we're going to get a number that when we square it, we'll get a positive 1. So I'll square a 1 and I'll get a positive 1. Then I'll square a negative 1 and I'll get a positive 1. So it turns out we actually got two numbers that when I square them, I get a positive 1. Okay? All right, so piece of cake. Well, what happens if we look at something like this? So what if I do something like x squared equals negative 1? Well, what does this mean? This means the same thing. It means I need a number that when I square it, it equals a negative 1. Well, look at your real numbers, right? And a real number is any number from negative infinity to infinity. There are no real numbers where this happens, right? If you square a positive number, you'll get a positive. You'll never get a negative. If you square a negative number, you'll get a positive. You'll never get a negative. And if you square 0, you'll just get a 0, right? No sign. So there are no real numbers that do this, which means we need to come up with a number. So we have to invent an entire new number system that fits this problem. All right. And that's what they did a long time ago. So, for better or worse, right, they didn't believe that these numbers really existed, so they called them imaginary. But it is a complete number system, right? And it's involved in all walks of life. All right. So complex and imaginary numbers are real. It's just a different number system. Okay. All right. So they decided way back when that they're going to call this number, so this special number, which they labeled as a letter, right? So we'll call it I, which is okay, right? We have other letters that are numbers. Pi is a number, right? So we're not afraid of that. So I is this special number that when I square it, I'll get a negative 1. Okay, so now keep this in mind. This was just invented to solve this problem. All right. So we have a whole, it's like coming up with a new vocabulary word, right? So we have a whole new set of numbers now to solve this type of problem. All right. Such that if I square it, it will equal a negative 1. All right. Okay. So I squared equals negative 1. And we had to, again, come up with some idea that there's some number out there that, and it can't be a real number, right? It can't be between negative infinity and infinity. That when I square it, I get a negative 1, and we came up with this notation. We're going to put I. All right. So notice if I square root both sides, this means that I also equals a square root of negative 1. So I squared equals negative 1, and I equals a square root of negative 1. Okay. All right. So now let's go back and solve this equation. So I'll square root both sides. Again, I'll get my plus or minus. I know that the square root of negative 1 has to use this new concept we just talked about that we just developed, where I equals square root of negative 1. So square root of x squared is x. Square root of negative 1 is I, so x equals plus or minus I. All right, and again, let's go back. So what did I say? This equation it's a number that when I square it, I will get a negative 1. Well, let's try it. So if I plug in I and square it, as we defined, I squared is negative 1, so that works. And if we substitute in negative I, right, a negative times a negative is a positive. So I'll get a positive I squared. That will also equal a negative 1. So it works. Right? So this new concept actually fits this problem. It solves this problem. Okay? All right. So stop the video and you want to complete classwork problems 1, 2, and then 5. All right? Okay, so now we have this new concept to work with I. And I now is an imaginary number. It's to help us solve that problem of what can I square to be a negative. That's why it was developed. Right? So we know that I equals square root of negative 1. right? And how do we know this? Because we developed this idea that I squared had to be -1, right? So the whole purpose of imaginary numbers was to find a number that when I square it equals a negative. So we actually started with I squared, right? And from there we went to I equals the square root of -1. All right? Okay, well, let's keep going. Let's multiply it by another I. What's I cubed? So I cubed, right, will simply be an I squared times an I, right? When you multiply like bases, you add the exponents. And then I squared, we learned from the above, is -1. So -1 times I is -I. So I cubed actually just equals -I. All right, so we have I equals square root of -1. I squared is -1, and I cubed is -I. Well, let's keep trucking. Let's try an I to the fourth. So I'll get I squared, which we learned from the second part is -1, and I'll square that. Oh, I changed the fourth power into a squared, right? So remember, when you raise powers to powers, you multiply the powers, right? And actually, I have a slide in our notes for this later on. So I'll get an I squared squared, so -1 squared is 1. All right? Okay, and it turns out if I go I to the fifth, then I'll just have an I to the fourth, which is a 1 times I, and I'm right back here. So these are actually the only 4 that I need to simplify any imaginary number. All right? Okay, so I want to condense this into some notes. So write this in your notes. So I equals square root of -1, I squared equals -1, I cubed equals -I, and I to the fourth equals 1. Okay? All right, let's try a problem here. So before I do that, let's do our exponents. So when you multiply like bases, you add the exponents, right? And we've done a little bit of this in the previous slides, right? So here, right, if I had 2 to the 2 cubed times 2 to the fifth, that's going to be the exact same thing as 2 to the 3 plus 5, which is 2 to the eighth, okay? All right, and you'll notice when we do these types of problems, we're going to go backwards. We're going to start with 2 to the eighth and work our way all the way to what it would be broken up. So we're going to do 2 to the eighth, figure out that is 2 to the 3 plus 5, and then figure out that that had to have come from like bases. All right, so we're doing this just in the reverse order. Okay, and that's going to be very important to evaluating these imaginary numbers. All right, and the other one we talked about was when you raise a power to a power, you just multiply the powers, right, the numbers. So 2 cubed to the fifth is the same thing as 2 to the 3 times 5, which is 2 to the 15th. All right? Okay. So let's do this. Let's simplify this imaginary number. And what's going to happen is, since we only need those 4, I squared, I cubed, and I to the fourth, right? So we have those 4. It's going to always simplify to one of those 4. Okay? All right. So the key to these, so we need to make a note of this. The key to these is to recognize that I to the fourth is 1. So what we want to do is figure out how many I to the fourths are here. And when we do that, those will all just be 1. So we're really just going to figure out the leftovers. That's all we're going to do. Okay, so my job is to figure out how many I to the fourths there are. All right, so the first thing I do is I to the 23. I want to figure out how many 4s are in 23. And it turns out that there are, I can split this up into 20 plus 3 because I know 20 is 5 sets of 4, right? So I want to figure out this number here comes with how many times I can pull, or let's just do this, is divisible by 4. So you're going to separate this number into a number that's divisible by 4, the largest number that's divisible by 4, and then the remainder. That's what we're doing, okay? All right, so I to the 20 is just, oh, I'm sorry, I do my intermediate step. So remember when we add the exponents, that had to have come from multiplying like bases. So remember I told you we're going to do it in the reverse order. All right, so now I'm going to have I to the 20, and I'll break that up into I to the fourth times I to the fifth. Or I'm sorry, I to the fourth raised to the fifth. All right, and this is the power raised to power. So if this is a 20, that's the same thing as 4 times 5, and I can do 5 as a power and 4 as the inside power. All right? Okay, and so my whole entire job here, the reason I did these 3 steps was to get this I to the fourth. That's the reason why I did it. Because now I know that I to the fourth is 1. So I pretty much just removed all the redundancy. And I'm left with 1 to the fifth times I cubed, So this is I cubed. So I to the 23rd really equals I cubed. And we know from the previous one that I cubed is negative I. All right, so that's the deal here. You want to figure out how many I to the fourth you have, change those to ones, and then get rid of that whole piece. And when you do this, you're always going to be left over with, so see this leftover here is either going to be an I squared, an I cubed, or it could be just a one because you took out all the out of the fours, right? Or because the whole thing's divisible by four. All right, but that's it. So your end result, you're going to just either have a one, an I squared, an I cubed, or an I. That's it. Okay. All right. So we'll stop this. Well, it's actually the end of the video, but you want to complete classwork problems 10 and 13.